First question we have, in which we have to identify, shows a simple electric motor with a single rectangular coil between magnet X and Y. What we have to do, we have to add label to the empty boxes to the right of the figure to identify the label parts indicated. Okay, so we have to identify these parts. So this part is basically, it's a carbon brush, and this part is the upper part, that is commutator, or you can say it split ring. Okay, in the second part, the coil rotate in clockwise direction when viewed from point P. State which of the magnetic poles X or Y is the north pole. Okay, so it's rotating in clockwise direction, and we know the direction of current as there is a battery. This will be a positive terminal, this will be a negative terminal, so the current will flow from there this way, and the current will be in this way. Okay, and from there the current will be upside. So to find direction of magnetic field, it's a example of motor. So for motor we will use left hand rule. By using left hand rule, the first finger, the thumb, first finger and second finger, you have to stretch them perpendicular to each other. You have to align your thumb in the direction of force. So as it's moving clockwise, so force on the left side, it will be up, and current is going down. So align your finger, your thumb upward, your second finger downward. The first finger will indicate you the direction of magnetic field. So the direction of magnetic field is basically like this. This is the magnetic field direction. So this will be a north pole and this will be a south pole. Okay, so X is north, X pole is north pole by applying left hand rule. So just two changes that cause the motor to spin faster. Okay, so to spin it faster, what we can do, we can increase number of turns, or we can increase magnetic strength. Okay, or we can increase the current as well. State the effect on the motor of reversing the connection to the battery. Okay, so if you reverse the direction of current, rotation will be reversed. Okay, so rotation reversed. Okay, changing the magnetic field or changing the current will reverse the direction of motion. The battery in figure 9.1 is replaced with a resistor. The coil is made to rotate by an external mechanism. Explain why there is a current in the resistor. Okay, now if we see the figure, what they are telling you, they are replacing this battery with a resistor, and they are rotating by some external mean. So it will become a generator in that case. Okay, because when you remove the battery and you rotate the coil by some external mean, that is a formation of generator. So when the coil will rotate in the presence of these magnets, there is a north pole, there is a south pole, there will be a change in magnetic field and it will produce a EMF. So that we have to explain. So electromagnetic induction take place when coil rotate between magnetic field lines, okay, and the current will produce. So the 2 mark questions, so that is enough. So and the second question shows a coil of wire rotating easily in the magnetic field between the poles of the permanent magnet. The current generated in the coil is to pass through resistor R. The apparatus in figure 10.1 is part of an AC generator. What is the connection between the ends A and the end B of the coil and the connections C and D? Okay, so we have to tell what should be at this point. Okay, so there is a slip ring for its slip ring and generator. Okay, so on figure 10.2, sketch a graph to show the variation with time of the current R. Okay, so we just have to sketch current. There is no initial position given, so we can start from anywhere, and there is no condition that you have to plot 1 cycle, 2 cycle, or 3 cycles. So we can start from 0 as well, and this is 1 cycle and this is 2 cycle. Okay, so I have drawn 2 cycles of the current. State 2 ways in which the graph would different if the coil spin at a faster rate. So if the coil spin at a faster rate, so in that case what will happen? The frequency will increase. Okay, if the coil will spin at a faster rate, so the graph will be, its amplitude will increase and its frequency will also increase. It will be like this. Okay, you don't need to draw it, but for your understanding, amplitude increase, amplitude mean current is increasing and frequency will also increase. Okay, suggest what could be connected between C and R so that the current in R is always in the same direction. Okay, so in the same direction mean you want to convert AC current into DC current. So for that purpose, rectifier is used. Rectifier, and rectifier is made from diode, so you can write rectifier or diode as well. In the next question, a battery charger, inducer, transformer and a rectifier represent the transformer consisting of an iron core with 2 coils P and Q on the core. P consists of 40,000 turns and Q consists of 2,000 turns, where P is connected to a 230 watt AC supply. There is an EMF across the terminal of Q. You have to calculate the size of this EMF. Okay, so we have to calculate the EMF of Q. This is EMF of P, and these are the number of turns in P. NP, these are the NQ, and so from the transformer equation you have to find VQ, right? So VQ divided by VP is equals to NQ divided by NP. Rearranging them, VQ is equals to NP divided by it's NQ divided by NP multiplied by VP. Putting the values, we get Vp is 230 and Nq is 2000 divided by 40,000. It will be 11 point something, that is nearly equals to 12 watts. Explain how this EMF induce. Okay, so basically you have to write down the whole mechanism of transformer. So the AC current in primary coil produce changing magnetic field lines. They pass through secondary coil. The change in flux through secondary produce EMF. Okay, so that is the complete answer. The output of Q is connected to the rectifier. The name of the circuit component that is used in a rectifier circuit, okay, it's diode. Diode is used as a rectifier. The property of this component that is used to rectify the current, its property is it conduct current only in one direction. Okay, this is its property. Okay, the next question is, name the process that causes a potential difference across a solenoid due to the movement of nearby magnets. Name of the process is electromagnetic induction. Okay. And the second question, describe the movement of the pointer of the meter. Basically, in the question, they're asking you when they move the magnet, the north pole, close to the one of the solenoid, the magnet is pushed into the solenoid and then brought to rest, and its north pole just inside the solenoid. Describe the movement of the pointer of. Okay, so when it move, when the magnet move the with motion of magnet, pointer will move and come to rest with magnet. Okay, the magnet is now pulled to the left out of the solenoid at a higher speed. Okay, so there are 2 points, it's in the opposite direction and it is at the higher speed. Compare the movement of the pointer of the meter with that seen in 1. Okay, so now due to the opposite direction, its deflection will be opposite, so pointer will deflect in opposite direction. As the speed is high, so the magnitude will be greater with greater magnitude. Okay.